In this lesson, we're going to take a look at the different algebra properties and how we can use them to rearrange math problems. The first property we're going to look at is the distributive property. All right, what the distributive property means is that we can distribute each number outside the parentheses to every number inside the parentheses. So there's two different ways we can look at each problem that has parentheses with it. I'm going to look at this first example here that says 3 times parentheses 4 plus 6 it equals 3 times 4 plus 3 times 6. What we're saying is this: if we take 4 plus 6 and do our using our order of operations, do our parentheses first, 4 plus 6 is 10, and then multiply by 3, 3 times 10 is 30. Or we could take the same numbers and do 3 times 4 is 12, plus 3 times 6 is 18. And when we do 12 plus 18, we get 30. Same answer. All right. We can do the same thing with 5 times 7 plus 3. Let's take a look at that example. I can do 5 times 7 is 35, plus 5 times 3 is 15. And when I put those two together, I get 50. Or I can do 7 plus 3, parentheses first, is 10, and 10 plus 5 is 50. What's important is that we take the number outside the parentheses and we distribute it or give it to every number inside the parentheses. Then the operation sign tells us what to do with our two answers. Again, we take the 5 outside the parentheses and distribute it to both numbers inside. So what you're going to be asked to do in the distributive property is to use the distributive property to rewrite math expressions another way. The first way we'll look at is if I'm going to do 7 times 4 plus 3. I'm going to do the parentheses first, but I want to rewrite this another way. So I want to distribute the 7 to the 4 and to the 3. So rewriting this using the distributive property, I'd say is the same thing as 7 times 4 plus 7 times 3. And if you check your math, you can see that 4 plus 3 is 7, and 7 times 7 equals 49. Or 7 times 4 is 28, 7 times 3 is 21, and 28 plus 21 is 49. So either way works. Let's try that on 5 times 6 plus 2. I have the 5 that needs to be distributed or given to both the 6 and the 2. So this problem rewritten using the distributive property is 5 times 6 plus 5 times 2. Same problem, broken up in two smaller problems. All right. Now, we can go the other direction. You'll notice in these first two problems, we went from number outside the parentheses and addition inside the parentheses. Now we're going to go the other direction, and we've got two separate addition problems that we want to break down and make look like problems 1 and 2. So we're going to go the opposite direction. Let's look at that. Here I have 3 times 9 plus 3 times 6. The common number is 3, so that's what goes. I have a 3 here and a 3 here. So that's what goes outside the parentheses. Now inside the parentheses is my 9 plus my 6. So I shorten this up to 3 times 9 plus 6. And if we take a look, we can see again that you're going to get the same result. I have 3 times 9 is 27, 3 times 6 is 18, and when I add those together, I get 45. Or I can take 9 times 6 is 15, and 3 times 15 is 45. You see, once again, same answer, whichever way I do it. Let's take number 4 and rewrite that one. I can see that right now it's written the long way, 6 times 17 plus 6 times 3. So I'm going to take the common number, which is 6, and the two numbers in parentheses, I have 17 plus 3. So I have 6 times 17 plus 3, rewritten using the distributive property. Here's an example of how we can use the distributive property to maybe make a longer problem two shorter mental math problems. It says a grocery store sells an imported specialty cheesecake for $11 and its own store-baked cheesecake for $5. Use the distributive property to mentally find the total cost for six of each type of cheesecake. Now I could put them together, say it's 11 plus 5 is 16. I need 16 times 6. That's a lot of math to do in your head. But take a look. How about 11? I'm getting $11 for 6 of the first type of cheesecake. You might be able to do in your head 11 times 6 is 66. Right? You also might be able to do in your head $5 for 6 of that flavor is 5 times 6 or 30. And you can probably do in your head then easier than 16 times 5. 66 plus 30 is 96. So it breaks that problem down into two smaller problems with smaller numbers that you might be able to do mentally. So that's the distributive property. Taking numbers, right, that have all addition and parentheses and rewriting it to distribute the outside number to every number inside, and then do your adding or your subtracting. The next set of properties we're going to look at are the real number properties, and there's several of these. So we're going to break each one down and look at them one step at a time. We have, first of all, the commutative property. And the way we talk about this in class is if you think of commutative as community. In a community, order doesn't matter. Nobody's more important or less important than anybody else. The commutative property tells us that order does not matter. What that means is that when we add, order doesn't matter. When we multiply, order doesn't matter. All right, so for example, I can say 5 plus 4 equals 9. I could also say 4 plus 5 also equals 9. Okay, the commutative property tells me that order doesn't matter when I add. Either way, I will get the same answer. This also works for multiplication. All right, a times b equals b times a. That's telling me the same thing. I can do 3 times 6 equals 18. Or I could do 6 times 3 also equals 18. Right? Because order does not matter when I multiply either. Now it's important to remember that this only works for It's important to remember that this only works for adding and multiplying. All right, not subtracting. For example, if you take a look at subtracting, we have 12 minus 7 equals 5, but we can't do 7 minus 12. That's getting us into negative numbers, which we haven't done yet. So the commutative property only works for addition and multiplication. The commutative property tells us that if your problem is an adding problem, you can do them in either order, or if your problem is a multiplying problem, you can do it in any order. The next one we're going to take a look at is the associative property. And the associative property works because of the commutative property. In fact, you're going to see it's very similar. The associative property tells us the way in which three numbers are grouped when they are added or multiplied does not change their sum or product. Basically, the associative property also tells us that order doesn't matter, but it tells us that order doesn't matter when there's parentheses. The easiest way to tell between a commutative property example or an associative property example is, are there parentheses? If you're looking at an example and you say that this is an example of order doesn't matter, then the next question is, are there parentheses involved? And if there are parentheses involved, you know it's associative property. Let's look at an example of the associative property. If I were to say 4 plus parentheses 7 plus 2, okay? Or I were to take 4 plus 7 parentheses plus 2. If you take a look at what happens here, I do my parentheses first according to order of operations, and I have 7 plus 2 is 9, and then 9 plus 4 is 13. Or I can do 4 plus 7 is 11, and 11 plus 2 is 13. Notice again, wherever I put the parentheses, I get the same order. And the reason is the parentheses don't change much because when it's all adding, order does not matter. One more example with adding. Take a look at one more example. We'll say 5 plus 8 in parentheses plus 2 compared to 5 plus 8 plus 2. Okay, you'll see this again here. Same problem, just different numbers in parentheses. If I take a look at the parentheses first in the blue problem, 5 plus 8 equals 13. And 13 plus 2 equals 15. If I take a look at the black problem, I have 8 plus 2 is 10. And 5 plus 10 is 15. Once again, where the parentheses are doesn't matter as long as everything is adding. We'll look at the same thing with multiplying. We'll look at the same thing with multiplying here in one quick example. We'll make that 3. So we'll say 3 times 4 times 6. Or 3 times 4 times 6. If you take a look at the red one first, we have 4 times 6, do our parentheses first. 4 times 6 is 24. And 24 times 3 is 72. Let's do the green problem. 3 times 4 is 12. And 12 times 6 is 72. You can see once again whether the parentheses are on the first two numbers or the last two numbers doesn't change my answer. So the associative property tells me that the parentheses don't matter as long as the problem is all adding or all multiplying. Associative property, order doesn't matter, and you can ignore any parentheses. That's the difference between associative and commutative. If there's parentheses involved, it's associative. And the last one we'll look at is called the identity property. And the identity property tells us that any number plus 0 equals itself. It also tells us that any number times 1 equals itself. If you think of identity, what is an identity? It's what you are, it's who you are. The identity property tells us that the number keeps its same identity. It does not change. So if I take 7 plus 0, the 7 keeps its own identity. It still stays 7. If I take 28 plus 0, the 28 keeps its same identity. It's still 28. All right. How about with multiplication? If I take 54 times 1, the 54 keeps its own identity. It's still 54. If I take 18 times 1, it's still 18. Its identity does not change. So the identity property tells us that a number plus 0 stays the same, or a number times 1 stays the same. The last thing I want to look at is what you're going to need to be able to do is look at problems and identify which property is being shown. All right. So for example, if we look at the directions, it says name the property shown by each statement. Number 4 says 9 times 1 equals 9. 9 times 1 equals 9. What that's telling me is this number times 1 keeps its own identity. So I'm going to label that the identity property. Right. Number 5 tells me 7 times 3 equals 3 times 7. 7 times 3 equals 3 times 7. Well, it's a multiplication problem, and they just changed the order of the two numbers. So that's telling me order does not matter when I multiply. So now it's got to be either commutative or associative. So the next question for myself is, are there parentheses involved? There are not parentheses involved. So this problem is associative. Excuse me, commutative. All right, commutative. If there are no parentheses involved, it's commutative. All right. Now, 6. Just getting a step ahead of myself. Here you see 7 plus 8 plus 2 equals 7 plus 8 plus 2. All right. The only thing that's changed here is where the parentheses are. And the one that tells us order doesn't matter with parentheses, that one is now associative. Just to clarify that with a little misspeaking there, if there's no parentheses involved, order doesn't matter is commutative. If there are parentheses involved, order doesn't matter is associative. All right, number 7 shows us 6 times parentheses 3 plus 2 equals 6 times 3 plus 6 times 2. You'll notice in this one we have the 6 distributed to the 3, 6 times 3, and we have the 6 distributed to the 2, 6 times 2. So this is an example of the distributive property. Next, we'll move on to number 8. Number 8 says 15 plus 12 equals 12 plus 15. It looks like all they did was change the order of the numbers. It was 15 plus 12, now it's 12 plus 15. Do I see a parentheses involved? I do not see parentheses involved, so it's got to be commutative. All right. 9 says 1 times 20 equals 20. A number times 1 equals the same number, or keeps its same identity. So we're going to call that the identity property. 2 left. Number 10 says 9 times 5 times 2 equals 9 times 5 times 2. You'll notice the only thing that changed here is that the parentheses was around 9 and 5. Now it's around 5 and 2. Both problems are all multiplication, so that would be associative. Associative property tells us that you can put the parentheses anywhere if the problem is all multiplying or all dividing or all adding. And number 11. Number 11 says 3 equals 0 plus 3. A number plus 0 stays the same number, keeps its same identity. So that's an identity property. This is probably the toughest part of what you're going to do with the algebraic properties, is being able to look at two problems side by side, written slightly different, and identify which property it's an example of. Right? It'll take a little bit of practice. It'll take a little bit of time, but you should be able to identify each example as either distributive, associative, commutative, or the identity property.